It's great to be speaking at IstioCon again. Today I'll be talking about the virtualization or virtualizing the Istio Sidecar, or more really the data plane and some of the trade-offs that can be made, in the data plane. So Shri introduced me. I don't need to do that anymore. I will leave my contact information here. I definitely encourage people to reach out afterwards if they have questions or follow-ups or clarification or comments. Reach out. Don't reach out, however, if you want to put me on some kind of mailing list and send me all kinds of advertisements and all that stuff. I already have enough of that. Thank you. I've also put on here a discount code for Istio in Action, a book that Renor and I released back in March with an awesome forward written by Eric Brewer. I will be out at Service Mesh Con EU in May, so if you happen to have a copy, bring it by. I'll sign it. Or we'll give away the books there as well. Okay, so like Shri mentioned, I work at Solo, and what's Solo.io, and what's interesting about Solo is that, and why I came to Solo was to work full time on service mesh problems, or more accurately on distributed systems and application networking problems. And at Solo, we've been fortunate enough to be working with a lot of different deployments and types of deployments in enterprise and real world use cases, including some of the largest deployments of service mesh in the world. Now at Solo, we've built a very high concentration of expertise in this area. We have prominent leadership positions in the community, like on the technical oversight committee. And a lot of what we do, we try to give back to the ecosystem. We try to share what we've learned, especially around pushing some of the innovations and stuff that you may see around the service mesh. And the stuff that I'll be talking about today directly comes from our involvement in the community, and more so working with a lot of these large scale deployments, because enterprises are tricky, or you see things in the enterprise that you would never have guessed in the open source community if you're just hacking on software in this ideal world. The various ways that organizations structure themselves and have regulation and compliance requirements, and backward compatibility requirements. They've been doing things this way for so long, and just that inertia doesn't allow much change, or at least very quickly. But as organizations are modernizing and trying to figure out how to fit what they have today into this approach where they can move faster and adopt the technologies to enable that, we get to work on some of these difficult problems. And what, like I said, we'll talk about today is how the service mesh, or how this technology is applied transparently to the existing workloads. And this has always been a goal of the service mesh, because what we saw in the past and the challenges that would crop up are, when applications talk with each other, they need to solve for certain application networking type problems, things like service discovery and load balancing, all the stuff that we typically talk about when you're talking about service mesh. In the past, the way this was done was kind of push all of this stuff to some central team, that this silo that we build, whether it's a ESB or API gateway, or some other team will try to solve all of these problems for us. But as we modernize, what we've learned is that forcing everything through these centralized systems, these centralized teams, creates bottlenecks and actually slows things down. We can't move as quickly as we'd like. So we need some balance between distributed approach to solving this problem, giving the teams in this model more autonomy to be able to define what the configurations and what the behaviors look like without actually having to code this into their applications, and without having to go to some centralized team for every little change that they need to make. So there's trade-offs to be made here, right? And that's going to be the central theme through the rest of this talk is what are the trade-offs, what are the benefits, and what are some of the drawbacks of doing this? Because what the service mesh does is say, here, let's create this data plane, these sidecar proxies, and deploy them next to the application instance on behalf of the application instance. And let's do this transparently. We shouldn't have to modify the applications to fit in with this model. Because if we have to do that, if you're working at a large enterprise, you want to make some changes. And to make those changes successfully, you have to go tell every single team that they have to change their code, that they have to stop what they're doing. That would never work, right? So being able to apply this behavior that the service mesh can bring, telemetry collection and security, improving security and encryption and identity, circuit breaking and load balancing, these types of things, apply that transparently to the applications. That's always been a goal of the service mesh. And specifically in Istio, there are a handful of things and mechanics that happen that try to enable this. So if you're familiar with Istio, you can automatically inject the little sidecar proxy that then acts on the behalf of the application to implement some of these application networking concerns. And in Kubernetes, there's a webhook. When you install Istio, it creates a webhook that when you deploy a pod, it'll automatically install this sidecar. So the application developer doesn't have to worry about the fact that this is there. Now they have to label their namespaces correctly, so they're still not 100% transparent, but you have to be aware of that. And then the automation behind the scenes can take care of injecting the sidecar. Another thing that happens, at least by default, you can tune this, but by default, when you inject the sidecar, Istio also injects an init container that tries to do some of the IP tables wrangling that is required for the traffic redirection. This is also to support this idea of transparency, so that the app doesn't have to know that the proxy is there. The app doesn't have to talk to a port that the sidecar might be listening on, which requires configuration changes, maybe code changes. What it can do, the app can continue to talk to the outside world and the network as it was before, and then the IP tables under the covers will automatically redirect the traffic into the sidecar so that it kind of transparently shows up there. Now, there's other, approaches. You could use the CNI and so on to handle this redirect for security reasons and so on. But for the most part, the service mesh, Istio specifically, tries to be transparent to the underlying applications. Now, that's not entirely the case that we can achieve this transparency. Whenever you're introducing another component to an application deployment, there's going to be inherent, maybe sometimes unexpected conflicts and challenges that come up. Now, these are not totally new. I mean, people have talked about we've certainly worked with our customers that have run into these problems, and there are workarounds. But the point is, there are challenges to this transparent model. For example, when you have these two containers, one of them is a prerequisite and has to be up for the end application to actually work. What if it's not up? What if the pod and the applications are starting, containers, the webhook is injected, the sidecar, Now things are starting. You got two containers. They kind of race to see which one starts up first. And if the app tries to talk out to the network, and the redirection rules say, hey, no, you have to go through this proxy first, and that proxy is not there yet, then that call to the network will fail, right? And then the application will start reporting errors. Hey, I can't talk to the network. And then Kubernetes will probably see this as a fail and try to recycle the pod, and this race will start again. All right, now this is not as transparent as we would like, because this could cause the app to sit in a constant crash loop. Now there are workarounds and so on, but you see this problem on the other side when the pod is terminating. We've certainly spent a lot of time, a lot of hours debugging. Why is my app getting 503s? Why, when there happens to be events, churn events, that we start seeing all these errors, and it becomes very difficult to debug? Well, there might be other reasons, but there's certainly this crops up where an app, or a pod rather, is given the signal to terminate, and the Envoy proxy shuts down, the sidecar proxy shuts down and kills the connections that were in place without gracefully terminating and draining those connections. This is not transparent, right? When you deploy your applications and they need to talk to the network, you would expect that they should be able to talk to the network. And introducing the service mesh sidecar proxy shouldn't change that behavior, but it does. Another one that we've seen come up quite a bit is when you're trying to run a job or a cron job type workload, where you've deployed the application and it's expected to run for a certain period of time and then stop. But when the sidecar gets injected, that sidecar continues to run. That isn't part of the job. It doesn't know when to end. So now you get this state where the jobs are deployed, they run, they finish, but the pods are still there because Envoy, the sidecar is still there. Again, not all that transparent as we want. Another one that had come up in the past, at least, is less of a problem now, I would think, since Istio 1.10. But it got into the details of what network that the application was actually binding to, that it made a difference. There was an assumption in Istio that the app would bind to localhost. And so that any of the redirection rules, traffic came into the pod, the sidecar would try to interpret that and then redirect it to the right services running on localhost. But that was a little bit weird, because applications that specifically and explicitly expose their ports onto localhost, they don't expect outside traffic to reach them. That's why they are exposed on localhost. Now that's sort of changed more recently, but another example of how the applications themselves, when you add the service mesh, are not all that transparent. Here's the last one that I'll cover. When you deploy your pod or your application, your service, and it's accepting traffic, you might want to set up some sort of scaling metrics or thresholds that, if crossed, automatically let's scale up the number of instances here. And in Kubernetes, the horizontal pod autoscaler does exactly this. Now, if you add another container, in this case, the Istio Sidecar proxy, this changes the metrics and the weights of the metrics. So, for example, if you're looking for 70% CPU usage of the app, and that's going to be your trigger to scale up, if you add the Istio Sidecar proxy, now the calculation of those metrics is weighted differently, because now you have this second container that also has CPU requests and limits that changes the weight of that calculation. So you might be getting 70% CPU utilization on the app container, But because the Istio Sidecar container is there and it's maybe not getting as much CPU cycles, it's dragging down the actual calculated value, and it's not getting, and so the autoscaler net doesn't see it actually trip past that threshold. So it doesn't scale it, doesn't end up autoscaling or autoscaling as quickly. And then you can run into scenarios where now this starts to cause failures and potentially cascading failures. So the point here is that we want the service mesh to be transparent, but it's not always transparent. And the sidecar introduces some of these challenges, and we're just scratching the surface of how service mesh, with its good intention of being transparent, is not transparent. We covered three of a lot of different types of operational concerns. But when you start to deploy, here, let me skip to this. That's not the slide I was expecting. When you start to deploy in a large environment where you have multiple clusters, maybe lots of nodes per cluster, various organizational security standards that you have to uphold, failure, blast radius type things, architecting for high availability and failover. And then day two type operations like upgrades, the list of things and the list of concerns and the transparency of the service mesh starts to not become so transparent. So then, is the sidecar the only model here? It does changing the placement of the proxy make any kind of differences here? And actually, this is not that new of an idea or thought to go down, and explore. Back in 2019 at Service Mesh Con, actually, we'll jump over there real quick. I'm not going to go through those slides, but there's a couple that are interesting here. Where I talked about what is the service mesh data plane, and first established that the service mesh gives a nice API into this application networking behavior. And if you stop and think, API, so the service mesh is the API on top of how we configure a system like this. Well, API is a contract or an interface, right? And there needs to be some kind of implementation. So how that API gets implemented can vary and should be able to vary in the service mesh. And so in that talk, I went through, the sidecar proxy is one model that we typically see because it's it takes a certain approach to isolation and security that we wanted to scope that down to the level of the application instance. But looking at implementing some of the service mesh capabilities, the proxy, the data plane in the application code for certain niche use cases where latency and performance is critical, that's also a viable approach. And back then, the Envoy API, the Universal Data Plane API, was being pulled out and kind of implemented in the gRPC project, and console service mesh also showed some signs of being able to implement this, and that's a viable approach. But so is going to the other extreme, maybe bringing in gateways and we see this in Istio today, being able to use gateways to control the flow and when you cross boundaries and network boundaries, what traffic and additional enforcement points need to be in place. So this idea of the various trade-offs that can be made for the data plane is not all that new. Now, in practice, like I said, in large deployments where you have VMs, where you have a lot of sidecars, a lot of clusters, public cloud, private cloud, different types of Kubernetes, DMZs, all this stuff, you end up with a lot of proxies that get deployed and a lot of overhead. And like I said, the transparency of the mesh starts to fade away. So, what are things that we can do, or at least explore, in terms of optimizing what the sidecar or the data plane more generally starts to look like? And some of the areas that we've been working with our customers kind of line up in these four categories. In terms of large deployments, where does the overhead conversation go? Right, because you're starting up all these proxies, all the CPU, and more like memory. Um, that overhead starts to add up. Things like feature isolation. So when these proxies, Envoy, which is what's used in Istio, are extremely full featured. You know, how do you separate out that a certain application A, wants to use some features without impacting and affecting other services? Or maybe they want to write extensions to the proxy. Maybe they have some Lua scripting, or they have WebAssembly modules that they want to use. Keeping that separation, that blast radius down when things go wrong is important to them. Security granularity. How is a big part of what the service mesh provides is identity. Assigning, or at least participating in assigning the identity, um, and scoping that down to the level of application instance. And then lastly, it's how do you operate this thing, and how do you actually do upgrades and patching CVEs? This is software. Things change, their bugs are found, and we need to quickly find them and fix them. So there's this constant operational toil around upgrades that need to be accounted for. Now, just as a side note, there is other technology that comes into play here when we start thinking about how do we optimize the data plane, and what are some of the components that could work in concert or complementary to the sidecar, that should be taken into account. And at Solo, we're doing a lot in this space. And as the program unfolded today at IstioCon, Edith Levine, who is the CEO of Solo, she spoke about the eBPF parts a little bit more in her session. So if you're watching this recorded later, then go back and look for the session there. It should be fairly complimentary. So let's take a little bit closer look. So we talked about the data plane as a sidecar. We talked about it as it being a spectrum and various types of implementations that could crop up. But we also have to think about this in terms of the trade-offs, in terms of memory, CPU trade-offs, resource overhead, in terms of security itself, feature isolation, and upgrading. So the service proxy is the most common model that we've talked about, where the sidecar gets deployed with the service instance. Traffic is ideally transparently forwarded through the proxy and between the different applications. Now, there are certainly some trade-offs to be made here, and if you look at the four categories that that give us the guidepost of the things we might want to optimize or trade off. In terms of resource overhead, this is the most suboptimal, we could say. Each proxy owning memory and CPU usage and so on, this starts to add up in large deployments. Feature isolation, however, is pretty optimal. So application A, they can write their own plugins. Maybe they need HMAC or some interesting ways to enrich a message or do some transformations. That can live with service A in isolation without affecting the other applications that might use the service mesh. Right? And if something goes wrong, that will only impact those applications. Security granularity, we're able to give identity and attest identity down to the level of the application instance and assign an identity that then, when originating things like TLS or mutual TLS, we can be sure that the granularity is as tight as possible. And the last bit is upgrade impact. It's not ideal because the applications, like we said earlier, are actually running with the sidecar, and making changes, doing upgrades. You do have to redeploy the applications themselves, which with good automation and so on, that's not, it's kind of sort of a toss up. But there are trade-offs, which is the point. A second pattern that gets explored is this idea of, well, let's just collapse all of the sidecars down into a single sidecar and have that sidecar really be a shared proxy per node or per host. And this approach requires additional infrastructure and automation to support additional complementary components in the networking stack. This is where eBPF may come into the picture, where the CNI could come into the picture. And here we're optimizing for resource usage. And if we take a look at the trade-offs that we might make, we can see that resource overhead, when we just have one proxy that's handling the traffic for all of the apps on that node, we can amortize the cost of that proxy. And so we have less overhead, but we trade off at the expense of things like feature isolation, where if I deploy a WebAssembly module to the shared host here, shared proxy, and that starts to take down or misbehave somehow and starts to take down the proxy, then I've affected every app on that host. And these types of shared proxy problems crop up all the time. Whether that's service mesh, looking at it through service mesh or API gateways or whatever, shared infrastructure will always have some amount of this trade-off. And the same can be said around the security granularity. Now, we're looking at the granularity of a host instead of an application instances. However, operationally, upgrading a proxy like this becomes a little easier. It's not deployed with the application. And if we upgrade this shared proxy, then all of the pods, all of the applications on that host get the benefit of that. Right? So you start to see how if you go one extreme, you have terrible resource usage, comparably really, but all of this isolation. And if you go the other way, then you start to make these trade-offs. Now, are there middle grounds? Yes, just like we talked in 2019 about how the data plane is a spectrum. There are, that feeds into, there are middle grounds. Can we do maybe not a shared proxy per host, but maybe a shared proxy per identity or per service account, and have, you still have a lot of the proxies, but not as many. So you start to trade off things like resource overhead is better. You still get some amount of feature isolation, and you might lose some of the or keep some of the security granularity and get some of the benefits of the upgrade impact. Now, this is these models we're exploring and talking with our customers and trying to understand. A lot of it we can kind of do with Istio today, at least in terms of how you position the gateways, and but there's still a lot to dig in and try to understand here. But knowing that there are trade-offs and that there are benefits to the current approach and benefits to these other approaches is important when you start to explore service mesh technology, Istio, or what are other service meshes doing, and so on. The last bit is, can we continue to optimize the per service account approach? and maybe move off the proxies completely off of the node. This then continues to optimize in terms of resource overhead, and try to keep some of the feature isolation and security granularity. Now, one thing that's not pictured in here is probably going to be environmental specific. Is now you probably introduce more hops and areas where things could fail, and so this is none of these are panaceas, and that we have to kind of understand what are the trade-offs that we're willing to make. So the session was really a discussion of some of the challenges around trying to run or keep the sidecars virtual or transparent to the application workloads. Some of the things that we're exploring with our customers, and there's a lot more to the story. Definitely check out Adit's talk earlier today about how eBPF starts to come in and sort of layer in the foundation for being able to do some of this stuff. Take a look at some of the other sessions. Some of our other solo colleagues have contributed. So Lynn spoke earlier, I think yesterday, about integrating external CAs, testing Istio's VM capabilities. Multi-tenancy is a very important topic to our customers. Definitely go check out some of those sessions. So with that, I'd like to wrap up and thank you for joining. Please do reach out if you have any questions, thoughts, would like to contribute ideas to what was presented here, or if you're going down the path of using Istio. We have a lot of experience and expertise in this area. Would be happy to work with your teams to make you successful doing that. So with that, I'll hand it back to the moderators here and get things moving to the next session.